about reduction formulas. How can we use them? Why they are useful when we want to find the sine or cosine function of an angle that is not as a standard angle. So we will talk about what are the reduction formulas, and I will also demonstrate examples for you how you can use the reduction formulas to work with equation, to work with trigonometric functions of non-standard angles. So our topic for today is reduction formulas. So what are the reduction formulas? So the trigonometric reduction formulas help us to reduce a trigonometric ratio to a ratio of an acute angle. If the acute angle is a common angle, this technique helps us to find the ratio. For example, if you imagine that you are given cotangent of 300 degrees, how can you find, or how can you tell immediately what is the value of cotangent 300 degrees? We do not know. Even the table of a standard angles doesn't give us this information. But what we can do is the following. We all know that we can represent 300 degrees as 270 degrees plus 30 degrees. So then what we will get? We can take this cotangent of 300 degrees and write it as a cotangent of 270 degrees plus 30 degrees. So then after that, we have to perform some other work as well, because we cannot stop. So we just split 300 degrees into 270 degrees plus 30 degrees. But we didn't get the precise value, or even the value that the cotangent of some acute angle or some angle that we know. So we can write exactly the value of it. So using reduction formulas, we will see how can we proceed further with this expression cotangent of 270 degrees plus 30 degrees. So to finish this calculation, we will need to start with the following. The first step here will be that we have all to recall the unit circles with the signs of all trigonometric functions. So what do I mean under it? So I will sketch a unit circle. It's the circle with the radius 1. And we will remind ourselves all the signs of all trigonometric functions with the respect to each quadrant. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So I'll just write it here, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So let's, for instance, start with a sine function. So I'll just write here sine alpha, okay? So we will be talking about sine function. So we know that the sign of this trigonometric function, sine function, actually is associated with the appropriate axis, y-axis or x-axis, and then we just look at the quadrant and we will see, like, if the y value in this quadrant has a positive value, then the sine function has a positive value. If the y value in this specific quadrant has a negative value, then the sine function also has a negative value in that quadrant. So let's look, for instance, in the quadrant, at the quadrant number 1. So here we may see that the y-axis, it's this vertical axis, has a positive value in the first quadrant and in the second quadrant. So for the sine function, we can immediately write that it will have a positive value here and the positive value here. So in the first and the second quadrant, sine will have positive values. And then correspondingly, we may see that the y-axis right here gets all the y values are negative. So that means that the sine function in the first quadrant and in the third quadrant will also have the negative value. And then similarly, dear students, we do for cosine function, and then for the tangent function, cotangent function, secant function, and cosecant function. So let's maybe complete this unit circle with the corresponding signs for the cosecant function, because we know that cosecant is just the reciprocal to this to the sine. So we will just write it like this. So actually cosecant will have the same values as a sine because it's just reciprocal to sine. So cosecant will be also positive here, negative here, and negative here. Okay, dear students, now we'll do the same job for cosine function. But now you all know that the cosine function is always associated with the x-axis. So we need to look where x values get positive degree, where do they get negative degrees, so then we can state the value of our cosine function there. So I will just name here my cosine function, cosine alpha. And then it means here, dear students, that x values, where are they positive? They are positive here in the first quadrant. They are also positive in the fourth quadrant. So I can write immediately that this has a positive value, cosine has a positive value in the first and the fourth quadrant. And then cosine will have the negative values in the second and the third quadrants because x value is negative there. And then similarly or correspondingly, we can determine all the values for cosecant. Because what we know, for secant. Because what we know is that secant is the reciprocal to the cosine function. So since secant is reciprocal to the cosine, it will have the same values. So we'll just have here positive value, here negative. So then, dear students, what remains is just the tangent and cotangent functions. So let's make the last final unit circle for both tangent and cotangent. So we will just draw this angle right here, this unit circle right here. Okay, good. So what I want to work on now is the tangent and also cotangent. Okay, so what do we know? Like to derive values for the tangent and cotangent function, it will be very easy for us because we know how to express tangent and cotangent through sine and cosine. So cotangent is exactly the cosine alpha over sine alpha, and tangent is the sine alpha over cosine alpha. So to just fill out the third circle, we just have to combine the values from the first unit circle and the second unit circle. So let's see, how will we do that? Let's look first for tangent, dear students. So it is sine over cosine. So let's see, what was the value of the sine function in the first quadrant and what was the value of the cosine function in the first quadrant? So they were both positive, plus and plus, which means that the tangent will also have a positive value plus. Now, if you look for the second quadrant, the sine was positive here, but the cosine was negative. So positive over negative gives us negative. And then similarly for the third quadrant, here sine was negative and the cosine was negative. So we will have negative over negative gives us positive. And then you can fill out the fourth quadrant by yourself and you will find out that it has a negative value too. Now, let's work on the cotangent values. Same as with tangent. Cotangent is cosine over sine. So let's see, what was the cosine in the first quadrant? Positive. The sine was positive too. So that will get value positive. And then here it will be negative. And then for the third quadrant, it was positive, so it will stay positive. And for the fourth, it will be negative as well. So they just coincide for tangent and cotangent because what you're doing. So tangent is just reciprocal to cotangent, or cotangent is the reciprocal to tangent. So they have the same signs in these fourth quadrants. That's it, dear students. So let me remind you one more time. We are talking about reduction formulas, and we want to know how they help us to find the values of trigonometric functions which do not have of the non-standard angles. So as I told you, the first step that you have to perform, or that you have to know, is the signs of trigonometric functions in each quadrant. So you need to know that. Second, what you also need to know is the following. Second, we need to remember the following, dear students. So if we have the following angles, pi over 2, which is equivalent to 90 degrees, or 3 pi over 2, which is actually equivalent to 270 degrees. In the reduction formula, then the formula changes sine function to cosine, or vice versa, cosine to sine, and tangent to cotangent, or vice versa, cotangent to tangent. It just depends on what you have. If you have sine in your formula, then it will change to cosine. If you have cosine in your formula, it will change to sine. And the same with tangent and cotangent. And this happens, dear students, only if you have in your reduction formula the pi over 2 angle, which is 90 degrees, or if you have 3 pi over 2 angle, which is 270 degrees. If we have pi or 2 pi angles in our reduction formula, which is equivalent, this one to 180 degrees, and this is to 360 degrees. So if you have these angles in your formula, the function doesn't change in your reduction formula. So what does it mean? So the function does not change in our reduction formula. So it means that if you have sine in your formula, it will still stay as a sine, or if you have a cosine, it will still stay as a cosine, or if you have tangent, it will be as a tangent, or if you have cotangent, it will be as a cotangent. So that will not change. And here, dear students, to finish this application of reduction formulas, we have to look at the step number 3. So the step number 3 actually is relevant to the signs of trigonometric functions with respect to each quadrant that we drew here. So what do I mean, dear students? So I mean under it the following. So, dear students, if your original function in your reduction formula had sine plus, then it means the new function will have sine plus. If your original function in the reduction formula had sine minus, that a new function in your reduction formula will have sine minus. So what do I mean under new function? I told that if we have the angle 180 degree or 360 degree, the function will not change. But I'll just keep it as following. So I may say, like, if you had here your sine function as your original function, you had here some angle, you did some algebraic calculations, like you were splitting the angle into two and as a sum of two angles or as a difference of two angles, and you here found that, oh, one of my angles was like 180 degree. So it means that your function will still stay here as your sine. So then what I mean under this rule number 3, if you had plus sign here for your original function sine, then it will stay as a plus sign here for your function sine after applying this reduction formula. Or if you have sine minus for your original function, then you will have sine minus for your new function here. Maybe in your reduction formula, you have 180 degree, so then it will not change to cosine, so you will have minus sine. Or maybe you had in your here reduction formula like 90 degree, so you will get then a cosine here. So just please keep in mind, dear students, so if your original function had sine plus, then in your reduction formula, your new function will have sine plus. If your original function had sine minus, then after applying the reduction formula, your function will have sine minus. So after that, dear students, I would like to perform the following example with you. So we will see how it works on practice. So, for instance, we are asked to compute sine of 150 degrees. So what do we know about that? So we actually, like, it's hard to remember all the angles. Maybe 150 is even known, like you can find it, Google it, use calculator, but we don't want to use a calculator. We can just use a reduction formulas that will help us to calculate it. So what can we do, dear students? What can we notice here is that actually sine of 150 degrees can be in way. So we have 150 degrees. So what do we know about this 150? So we can write this 150 as 90 degree plus 60 degree, because 150 is 190 plus 60. So what we see here, dear students, is the following. First, I want to pause here because this first step is that we just split the angle 150 degree into two angles 90 and 60. So what I want to do now I want to first perform this checking of sine step. So let's see first, what was the sine of our original function sine of 150 degree? How can we check what was the sine of 150 degree? It's easy to do using the unit circle, dear students, because what is 150 degree? So all the angles up to 90 degree will be in the first quadrant, and then if you want to go farther to up to 150 degree, we will end up in the second quadrant, dear students. Because we know that this angle right here will give us 180, which is greater than 150. So 150 has to be less. So we will end up here in the second quadrant. So let's see, what was the sign of the sine function in the second quadrant? We see that it was plus, dear students, it was plus. So which means that this function, after applying the reduction formula, will not change its sign, so it will still stay plus. So it was plus, so it will be plus. So I can just write maybe here, I will just skip it for a moment. I think I'll just write it as a plus right here, because we will be applying the reduction formula. So I just want to indicate that the sign initially in the second quadrant had this plus sign, so the new function after applying the reduction formula will also have plus sign. So now we performed the step number 1. We checked the sign. Now the step number 2 that we have to perform is we have to check if our function, original function, will change to the opposite one, will change to cosine. So what do we have to do for that, dear students? We have to look for the angle. So let's see. Do you see something like 90 degree or 270 degree in this parenthesis? Yes, we do. We see that one part of this sum is 90 degree angle, which means that our original function will change to the opposite cosine function. So we will then just write here the cosine function. So this 90 degree here, dear students, exactly corresponds to this change. So sine will change to cosine. So we will get the cosine, and then we will get only this remaining part, which is 60 degree. So this 90 corresponds to change. So then we just don't use it anymore because we already applied it. So what remains? Only 60 degree, and we will get the cosine of 60. And now we know 60 is the standard angle, and we know that cosine 60 degree will give us 1/2. So we will get positive 1/2, just 1/2. Very good, dear students. So that was one example. Now let's look for another example, dear students. Maybe we can do something different. Let's, for instance, do another example. So, for instance, if I do, we will just finish the cotangent example here. So let's see. So we have here the cotangent. The cotangent is 300 degrees. So let's see how can we apply? That is even more interesting. So first of all, dear students, let me just write it down here, my cotangent. So we have cotangent 300 degrees. So what we already did, we found out that we can write 300 as 270 plus 30. Okay, so now we stop at this point. At first, what we will do is just let's check if the new function that will appear after applying the reduction formula will give us a different sign for that function. Like will we get like a positive value of that function, new function, or negative? So to do that, we again, dear students, take this cotangent of 300 degrees and go to the unit circle and look, where was that cotangent of 300 degrees? So we know that this is 90 degrees, this is 180, this is 270, and this is 360, the full circle. But we have 300. So we will end up somewhere in the fourth quadrant, dear students. So we will end up somewhere in the fourth quadrant. So that is our 300 degree. So let's see what sign cotangent has in the fourth quadrant. So cotangent is this yellow color. So it has minus. So our original function as a cotangent of 300 degrees has minus sign, which means after applying the third rule, we have to switch the value of our new function to the negative as well, because the original function had the negative value, which was the cotangent. So we will get here minus. Now, dear students, let's look at these parentheses value. So let's see, do we have something like 180 degrees, 360? I don't see. Do we have something like 90 or 270? Yes, we do. We have 270. So what that rule then tell us? If we have 270 degrees, in the reduction formula, the formula changes from sine to cosine and from tangent to cotangent. So in our case, dear students, we have the cotangent value. So it means that the formula has to change to tangent. So let's see. We then have just to write down here the tangent. And since we applied that reduction formula, the remaining angle value will be 30 degrees. So we will find out that actually cotangent 300 degrees will be minus tangent 30 degrees. And now we know what is the tangent 30 degrees. Tangent 30 degrees is 1 over root of 3. And that is our final answer. That's it, dear students. So let me go back and tell you what we considered today. So we considered today the reduction formulas that helps us to calculate the values of trigonometric functions for non-standard angles. And also it's a very, very useful tool if you're dealing with trigonometric equations as well, because very often the argument of the trigonometric function does not have this standard angle that you know, but it may have like the angle 300 degrees as we had, or maybe 15 degrees, or maybe 75 degrees. So when you know these reduction formulas, you can just reduce your trigonometric function of a non-standard angle to the trig function, trigonometric function of the standard angle. So then you will know the value. That's it, dear students. Thank you very much for your attention.